Section 4.1, continuing with exponential functions. This one is part 4. Okay, in the last video we said that there was going to be a part 3, part 4, and then we would be done. But I decided there's going to be a part 5. Sorry about that. But in part 4, when I went through the first recording, it ran over 10 minutes, and that's usually not a good length for a video. So I'm going to split these up into part 4 and then a last part 5, I promise. Okay, so we've been starting out with exponential functions and looking at their graphs. Anytime our base was greater than 1, we had a graph that increased. Anytime our base was a fraction, we had a decrease. Our graphs passed through 0, 1 unless there was a transformation. The horizontal x-axis is our asymptote. And then we looked at domain, all real numbers, range unless there was a transformation, a reflection on the x, or maybe an up-down change. Our range would change. If there's no transformation, our range is from 0 to infinity. But if there is a transformation, then this is going to change. So we wanted to remember that piece. Okay, horizontal asymptote, the x-axis. Okay, so when we graph exponential functions, it's very helpful if we remember our transformations and these basic properties for graphs. We looked at this example. We looked at a basic graph as 2 to the x power, and then we went through and looked at what transformations were being done on our basic graph. This was an inside, replace x with x minus 3. So when we did this example, we moved right 3 units. Okay, here we started out with a basic graph, which was 3 to the x. And then we looked at transformations. What were the transformations being done on 3 to the x? This was a flip on the x-axis. So we did that. And this one was an up 6 units. And we did that one. Okay, so here's where we left off. Let's look at this example. Okay, so when we were able to be in the classroom, how did we handle homework? We were able to work on our homework. We were able to turn it into class. I graded it and then hand it back. We don't have that system in place as we're going to a virtual classroom. The college is closed. Well, we can't get to campus. Faculty can't get to their office. Students can't get to libraries and tutoring centers. So without being in class, we have to figure out a way that we're going to work on homework now. We are going to switch from paper and pencil homework to online homework through WebAssign. Okay, so what does that mean? WebAssign is the software platform that goes with our textbook. WebAssign is through Cengage. The company Cengage gave all students free accounts. So you have a free account in WebAssign. In WebAssign, we're going to be able to turn in homework. And as you work on homework, there's going to be resources available for you within WebAssign. Within WebAssign, you're going to have an electronic textbook. So if you want to look at your textbook online instead of your physical copy, you have that for free. There are student resources in there that I want you to check out, especially the videos. So they'll have a video for section 4.1, for example, within WebAssign that you can also look at if my videos aren't helpful or you want some extra guidance. Okay. So as we do homework in WebAssign, here's how a problem might look for what we're talking about. Up here, we have section 4.1. This is a Stewart book, so that's S. Stewart is our author. In Math 188, we cover the sections that relate to college algebra. In Math 189, you're going to cover the sections involving trig. So this is Stewart, our author. We're using the college algebra sections, but next semester you'll be using the trig sections. We're in section 4.1, and this is an example homework problem 35. Okay, now don't get intimidated with WebAssign. It is a little bit of getting used to at the beginning, but don't worry about. We'll work together so that you're comfortable using it. If you have questions, I can help you with questions. But here's an example problem in section 4.1. Okay, so what did we just do? We graphed the function, not by plotting points, but starting from a basic graph. That was this part. So we looked at our basic graph. From the basic graph, we figured out our transformations. Flip on the X and up 6. Here's how it looks in WebAssign. Graph the function not by plotting points, same exact wording. Graph the function not by plotting points, but starting from a basic graph. So they're giving you the basic graphs. 1/2 to the X, 1/3 to the X, 1/5 to the X, etc., all the way to 2 to the X. So here, they're just giving us all at once pictures of a basic graph. Which basic graph do we want to use? We want to use the basic graph for 1/10 to the X. So we're going to focus just on 1/10 to the X. So we can get rid of all of these, we can get rid of all of these, and so the graph that we're going to concentrate on is just this one, which is 1/10 to the X power. Okay, so just like we did in this example, we figure out our basic graph, we figure out our transformations, and then we're able to graph. Okay, so the basic graph from here that we're looking at is y equals 1/10 to the X. We're only going to concentrate on that yellow graph, which looks like this. It goes through 0, 1. If X is equal to 1, we have 1/10 to the first power. So if X is equal to 1, we would be plotting 1/110. If X is equal to -1, okay, so plugging in -1, that would negative exponent bring the 10 up from the denominator. So we would be plotting -1, we're plotting -1/10. Okay, so we can see this is definitely not to scale, but we're just getting detail off of our basic graph, which was this yellow graph here. Okay, next, like we did here, we figured out our basic graph. Now we're ready to figure out transformations. Okay, so what transformations do we have with y equals 2 minus 1/10 to the X? What's our transformation? Flip on the X. What's our transformation? Up 2. So we're going to take this graph, we're going to flip it on the X, and then we're going to move it up 2. So 1, 2. Our horizontal asymptote, we're going to move up 2. So 1, 2. Our 1/110, we're going to move up 2. And what we should see is our final answer. Our horizontal asymptote is now at y equals 2. We move that up 2 units. We moved all of our plot points up 2 units. And so in WebAssign, what we should look for is a multiple choice answer that follows this graph. Okay, so our online homework is going to be very similar to our paper pencil homework. It might take a few sections to get used to the homework system, but we'll work together. Let me know if you're having difficulty, and we can work together to get our class successfully done. Okay, on to part 5.